All right, and we are back. Assalamu alaikum, everyone. Bismillah ar-Rahman ar-Rahim. In the name of Allah, the beneficent and merciful. I bear witnesses with one God, whose proper name is Allah, who came to us in the divine person of Master W. Fard Muhammad, the great Mufti, to whom praise be forever. I further bear witness to the most honorable Elijah Muhammad's living wisdom and exalted Christ, and the honorable minister Louis Farrakhan's of divine reminder, servant, order, and Messiah today. I'd like to greet the mighty SSOE high school geometry class with the green words of peace and paradise we say in the Arabic language. Assalamu alaikum. I pray we are all well, still moving forward, still learning much, still striving to become masters of this subject. As you all know, we started off with regard to this triangle congruence topic. But we didn't start off, we continued starting from last week talking about triangle congruence, and specifically side, 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 and side angle, side congruence. Today, we're going to continue that discussion, moving on to two additional acronym styled congruence types, which is angle, side, angle, and angle, angle, side congruence. So let's prepare, lock in, be ready to take notes, and let's get started. So here we go. I pray we see. All right. So you're in the new chapter, chapter 13, angle, side, angle, and angle, angle, side congruence. So there are additional ways to determine if triangles are congruent. Remember, this is building on side, 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 and side, angle, side. And the goal of this is for you all to look at triangles and determine if they're congruent, but have a full toolkit to do so. So angle, side, angle congruence. The angle, side, angle congruence postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are. So let's break this down like normal. If two angles and the included side if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangle. What does that mean to be included, right? The included side is a side between angles. It's a side between angles. So if we look at the triangle here, A, B, C, right? I'm going to go in the same direction for this triangle, right? D, E, F. I'm going from the smaller angle, A, to the angle with no arc measure to the angle with two arcs. Same thing here. Small arc or one arc, no arcs, two arcs. So A, B, C, D, E, F are congruent based on the angle side angle congruence. There's one angle, the side next adjacent to it, and the other angle adjacent to that is congruent to an angle included side and a follow angle in the other triangle. So if angle A is congruent to angle D, right, which is right here, angle A, right, angle D, we know this because they both have arc, one arc. The arc shows congruency for angles. And then it says line segment or side AC is congruent to side DF, right? Here we go, side AC. Put the side DF. And angle C is congruent to angle F. Then triangle ABC is congruent to triangle DEF. Again, the order, notice how they ordered it. Angle A corresponds to angle D in position. Angle B corresponds to angle E in position. Angle C corresponds to angle F in position. The order by which you write the notation for angles matters when talking about congruence. So again, a good way to look at this is the angles, the angle side and angle system is all in like a straight line. So you're going to basically see all the congruence portions along one side of the triangle. That's a great way to see it. So again, if for angle side angle congruence postulate, if two angles and the included side, right, the side between them of one triangle are congruent to two angles and the included side between them of the other triangle, then the triangles are congruent. All right, let's move on. Remember, included side, the side between two angles of a triangle. This is a great picture up top. Angle, angle, included side, right? Angle, angle, this will be the included side. If there was an angle and an angle here, this is the included side. So obviously there's an angle here. The included side in a triangle, basically technically all sides are included sides. It depends on which angle you're talking about. So the included side for this angle and this angle is here. The included side for this angle and this angle is here. The included side for this angle and this angle is here. Example. Let's zoom in a little bit more. Which of the following triangles are congruent by angle, side, angle? Again, answer the question that is asked. It says, which of the following triangles are congruent? It didn't stop there. By angle, side, angle, right? So not only are we looking for congruence, we're looking for congruence by this postulate. I know this seems like it makes sense. Well, Brother Jabril, we're already talking about this. The reason why I specified this is because not knowing the postulate can make it very difficult to know. But knowing the postulate knows what you're looking for and the type of orientation. So if we look at triangle A, B, C, we have angle A is 62 degrees, side AC is 17, and angle C is 67 degrees. Okay. And we also know that everything is along the shortest side of this triangle. Now, if we look at triangle DEF, we have angle F is 67 degrees. We have angle E is 62 degrees, and angle DE is 17. And then we have in triangle GHI, we have angle 50, we have angle I is 51, the side IH is 16, and angle H is 67. And then we have, so now, which one is congruent? So what we have to look at is the system that has two sides and the included angle. So let's start comparing, right? In ABC, you have a system that looks like what we're talking about. Angle A, 62 degrees, right? AC is 17, angle C is 67. Okay, so let's keep it moving. Well, here it has angle E is 62, right? We have a 62 here. Angle F is 67, we have it here, but the 17 is outside of the system. So as of right now, this doesn't seem like it might be the case. Okay, now we have angle I, right? Is 51, angle H is 67, and in between those is 16. But it also has something here, which is 17. So what we can do is we can also figure out, well, what is going to be the last measure? So if we take 180 and we subtract 62 and 67 in the first triangle, we get 51. So we know that this angle is going to be 51 here. This angle is going to be 51 here. And this angle is going to be 62 here because all three of these had some combination of the same angle. So now let's look at it. So now if we look at it based on our triangle angle sum, right? Triangle angle sum postulate, right? All three angles in the triangle add up to 180 degrees. So I knew that 180 it ends up equaling 51 plus 62 plus 67. So now that I was able to fill in all of the angles, I can more easily see what's congruent. Well, now if I look at this system right here, let's hone in right here and then right here. We have for side DE, angle D is 51, side DE is 17, angle E is 62. Right here, segment IG, angle I is 51, IG or segment IG is 17, angle G is 62. So because those two sides are congruent by the angle side angle postulate, those two triangles would be congruent by that same postulate. So it should be triangle DEF and triangle IGH. Right? So let's go ahead and see if what they came up with and how they explained it. Each triangle has a side length of 17. Those will be the included sides. Right, very important. The side length of 17 will be the included side we look at because it's shared amongst all three. Find the missing adjacent angle measures. So we understand measure of angle D, let's measure the angle E, let's measure angle F is 180 degrees. Measure of angle G, let's measure angle H, measure angle I is 180 degrees. So measure angle D plus 62, 67 is 180. Measure angle D is 51. Measure of angle G plus 67 plus 51 is equals 180. Measure of G is 62. So far, so good. Angle D is is congruent to angle I. And side DE is congruent to side IG, and angle E is congruent to angle G. As we said, therefore, triangle DEF is congruent to triangle IGH by the angle side angle congruence postulate, just like we came up with. Here we go. Even without knowing the exact measures of the angles and sides, we can prove that these triangles are congruent. Well, how can we do that? Right? We know that side QR is parallel to side PS. QR and PS are parallel based on the triangles. We also know that PQ and QP and RS are parallel. Use PS and QR as the parallel lines and QS as a transversal. See how we do that? At we're right back at what? A few chapters ago when we were dealing with systems of parallel lines and transversals. So if this is a transversal system, what do we know? Well, we know that we have two pairs of alternate interior angles, right? Two pairs of alternate interior angles. Oh, well, you know what? Let's go back. We know that that's a pair of alternate interior angles, right? Right here. So those are congruent, right? We know that this side in between is also congruent because it's a shared side. And then there's one more aspect that we can look at. So let's go ahead and see how they finish this up. So with that being with that parallel system being given, right? That means that angle SQR, and angle QSP, alternate interior angles are congruent. Oops. Okay. All right. So, sorry. Angle PQS is going to angle QSR. Side QS is going to side QS, the side that's shared by both triangles, paragraph proof. We are given that side QR, we're given this right here. QR and PS are parallel. And QP and RS are parallel. SQR is going to go into angle QSP. SQR right here. QSP right here. We know that by the alternate interior angle theorem. Also, side QS is congruent to side QS, right? Because it's a shared side by the reflexive property congruence. The identity is such that it's congruent. So we know that these sides are shared. So by the angle side angle postulate, right? Right? These are also, I'm sorry, these are also two. This is also a system of alternate interior angles, right? So now that we have the system, by the angle side angle postulate, we know that these two triangles are congruent. And this is even without knowing the actual angle measures and just leaning on our parallel lines and transversal systems that we learned before. So by the angle side angle congruence postulate, ASA, triangle PQS is congruent to triangle RSQ. PQS is congruent to triangle RSQ. All right, moving on to angle side angle, or sorry, angle side congruence. Angle side. So the angle side congruence theorem. If two angles and a non-included side, here we go, two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. Here we go. Two angles and a non-included side of one triangle are going to two angles and the corresponding non-included side. That's important. That's important because you can't have a random non-included side, right? It has to be the corresponding side based on the angle placement and side placement. So if you look here with A, B, C, and D, E, F, right? If angle A is congruent to angle D and angle B is congruent to angle E and BC is congruent to EF, then ABC is going to DEF. And notice it kind of goes around one after another, right? A to B to the side BC, D to E to the side EF. So again, you know it won't be the included angle, right? Because that's a different angle postulate. So it has to be one of the angles that are one of the sides that are opposite one of the angles, right? And you'll typically know what it is based on what direction you're going. So if you were going the other direction, you could do it here. If it was this side, it would have to be this side. I'm sorry, it would have to be this side on the other one. It still works, right? It still works. It would just so that it would just so in this example that B, C, and E, F were the ones that were congruent. It could have been the two, it could have been A, C, and D, F, and that would have still worked. So it's about the corresponding side being non-included. Just can't have different sides. Okay. Example, prove triangle ABC is going to triangle FDE. All right. So both triangles have a side length that is 12. So that's the only one we have. So we're going to go off of that being the non-included side that is corresponding and congruent. So this side and this side are going to be the sides for our system. Now, remember, it's angle, angle, side. So for ABC, it's you look at angle, angle, side, it would be A is 54, B is 71, then BC is 12. So that means you would have to go F is 54, D is 71, DE is 12. So let's see it. Angle A is congruent to angle F. So far, so good. Angle B, as in Bravo, is congruent to angle D. And then side BC is congruent to side DE. So this follows the pattern of angle, angle, side, or angle, angle, side. So by the angle, angle, side postulate or angle, angle, side postulate theorem, triangle ABC will be congruent to triangle DEF. And just like you said, so by the angle, angle, side congruence postulate, triangle ABC is going to, triangle FDE. All right. All right, here we go. Another example. Prove the two triangles below are congruent. So can we do this? Trick question, I know we can. So here we go. In triangle PQR, PQR, and triangle STR, we have a pair of congruent sides right here. And we have a pair of congruent angles with one arc, angle P and angle S. Excellent. One thing that should be abundantly clear from the work we've done so far is each of these systems thus far requires three components, right? Either three sides, two sides and an angle, two angles and a side. So right now we only have one side, one angle. And we know that we're doing angle, angle, side for our postulate. Angle, angle, side. So we are missing one angle of congruence that we can now take the approach with going angle, angle, side in like a kind of circular manner to figure it out. So what is going to be our last uh angle congruence? Uh what are the last two angles we can say are congruent based on this figure? Well, if I look around where it says where point R is, I see two cross lines. And we know that when we have lines that cross and intersect at one point, that those angles are vertical angles. So we know that these are congruent. So now by the angle angle side theorem, RST is congruent to RPS, angle, angle, side, angle, angle, side. That should be our answer. So given angle P is congruent to angle S, side QP is congruent to side TS, angle QRP is congruent to angle SRT. Vertical angles are congruent. By the angle angle side congruence postulate, angle PQR is congruent to angle STR. Last one. All right. Hypotenuse leg, HL theorem. This congruence theorem is specifically for right triangles. You will only use hypotenuse leg or HL theorem for right triangles. Okay? That's important. It's never hypotenuse leg when it's not a right triangle. It also doesn't mean that you can't use side, 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 angle, side, angle, or angle, angle, side for right triangles. It just means that when you have a right triangle, all you need is hypotenuse leg. If the hypotenuse and a leg of if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. If, so here we go. We have triangle ABC and triangle DEF. The leg here, AB, is congruent to the leg here, DE, and the hypotenuse here, BC, is congruent to the hypotenuse here, EF. That's all you need for this system to be congruent. If and because also angle A and angle D are right angles. Angle A and angle D are right angles. Side BC is congruent to side EF, and side AB is congruent to side DE. Then triangle ABC is congruent to triangle DEF. So as long as you have a right triangle and and two of the legs in each one, or one leg in each triangle is congruent, and and the hypotenuse in each triangle is congruent, then you have a hypotenuse leg system and congruence. Triangle congruence summary. All right. So as we land the plane, for side, 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 all sides are congruent. For side, angle side, two sides and an included angle are congruent. Two sides and a congruent and an included angle are congruent. Angle, side, angle, two angles and an included side are congruent. Angle, angle side, two angles, and a non-included side congruent, hypotenuse and leg of two right triangles congruent. Last but certainly not least, does side-side angle work to confirm the triangles must be congruent? So this is talking about, is there a world where SSA works? These triangles have two pairs of corresponding sides, congruent to each other, and a pair of non-included angles congruent, but they are different shapes. See? So notice, two sides are congruent, but they have different shapes. SSA is not a way to show congruence because you can have different configurations, different shapes with this system. Does angle, angle, angle work to confirm that the triangles must be congruent? These triangles have three pairs of corresponding angles congruent to each other, but are different shapes. Yes, they can have the same angle, but one triangle can be larger than the other. So AAA is not a way to show congruence. So angle, 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 and side, side, angle are not necessarily ways to show congruence and should not be relied on. These are not angle congruence postulates. These do not work. So with this, oops, these do not work. All right. So with this, we have concluded chapter 13. All right. Study hard. I pray everything made sense. You have time, obviously, to pause, go back, and take notes. I look forward to, inshallah, seeing everyone on our Friday review. Let's make sure we increase the amount that come out. Tell your classmates and make sure you're present for class, and we can go over any questions you have. I leave this okay before you. Reading words of peace in paradise. We say in the Arabic language. Assalamu alaikum.